So another comparison test that we have besides direct comparison, limit comparison, and integral test is what's called the nth root test. In a lot of ways, this behaves a lot for us like the ratio test does. Um, again, we are dealing with a series that has to have non-negative terms, but if we're doing absolute values, that gets taken care of. But what we are doing then is instead of looking at just the individual general term, is we're taking the nth root of that. If as n goes to infinity, that limit is less than 1, our series converges. If that limit's greater than 1, it diverges. Or if the limit equals 1, it's inconclusive and we have to use different tests. So you can kind of see there that it's very similar to our ratio tests in terms of whether it converges, diverges, or try a different test. I'll be honest, I personally do not use this one very much because of how early I try the ratio test. If the ratio test doesn't work, this one will rarely work. I personally just usually take the time on the ratio test instead. But in terms of an example here, if we were doing the series of the quantity n over 10 minus 1 raised to the nth power, I could do ratio tests. Integral tests would probably be a little bit tough, as well as limit comparison would be a bit tough. But if I take the nth root of this, that gets rid of the nth power, and I'm now left with the limit as n goes to infinity of plus the n over 10 minus 1, which I could do L'Hopital's rule on, I could do n behavior model on, because it's infinity over infinity, and n is going to infinity, but I get 1/2, which is less than 1, so this series